Let's say we are given this sequence. As always, when we're given a brand new sequence like this and we don't know what it belongs to, we look at the differences between each term. And looking at these differences, we can tell that the common ratio between the differences is 4. Now, this doesn't tell us much about how we can find the general formula. So let's look at a more generalized case and then return to this to figure it out. Let's say I have A0, A1, A2, A3, and so on. And just like in the last example, let's say they have a common ratio between their differences. Let's say the first difference is x, and the common ratio, let's say, is r. So just like in this case, where it was 4, our common ratio here is going to be r. That means that the differences are going to go plus x, plus rx, plus r squared x, and so on. And now that we have this, we can represent this as a0 plus, and we can use a summation because all of these terms can be just written as a summation because we're just adding terms to get the next terms. So the summation would be from n equals 1 to infinity, because it's an infinite summation. And then it would be, in this case, we know that r is raised to 1 here, r is raised to 2 here. So this can be just written as x times r to the n. And we also know that when we're given a geometric sequence, the sum can also be written as x times r to the n minus 1 all over r minus 1. So that means that this is our generalized form for our formula. So I'm just going to rewrite it. Right, it's just your first term and then plus the sum of your geometric series. Okay, and now that we have this to work with, we can easily go and solve our original question. So in this case, r is 4 and the first term is 1 and the difference between the first two terms is 2. That means a sub n is going to be the first term, 1, plus the difference between the first and second term, which is 2. And then r in this case is 4, so 4 to the n minus 1 all over 4 minus 1, which is 3. So I'm just going to rewrite this. So for 1, 3, 11, 43, the general formula would be and we can test this to just check if it works. So if we test this, and this is for n starting at 0. If we test this, then we have 1 is our first term, 3 is our next term, 11 is our next term, 0, 1, 2, 3, so 4 cubes is 64, so 63 over 3, 21, 42 plus 1, 43. So it matches. So we can tell that this is our general formula. And this can work for any sequence we're given which has a common ratio between the differences. And it's always a shifted form of the geometric sequence, and this can be shown right now. If we rewrite this, then we can rewrite it as and this can be expanded to be and we can tell that if we just look at this part here, we're used to this because it's just the geometric sequence, but now we're shifting it by some amount. So this is what this formula accounts for, is the shift here. And that's why I think this is a better generalization for the geometric sequence. So again, this is the general formula, and yeah, thank you for watching.